Welcome. So this question says a pendulum swings out 30 degrees from the vertical axis. The pendulum is 2 meters long. It has a 4 kilogram bob. And what's its speed at point B? So this is 2 meters. And this is 30 degrees. And so is this. And point B is here, so I'm assuming it's swinging in a counterclockwise direction, and this is going to be V, and that's what I'd like to find out. Well, it's an isolated system. There's no mention of friction, so it's an isolated system, and so the mechanical energy is the same at all points. So I can say find V using, I'm going to say the mechanical energy at A is equal to the mechanical energy at B is equal to the mechanical energy at C, and that my mechanical energy at C is equal to, well, at this point I know that the kinetic energy equals 0 joules because it's the end, it's the most extreme point on the path, and the velocity is a maximum at B, it goes to 0 at C, it turns around and is a maximum at B in the other direction, and again 0 at A. So I know at point C, well, it's going to be my kinetic energy at C plus my gravitational potential energy at C. There's no springs, so let's not even mention that. So I can say my mechanical energy at C is equal to 0 plus mgh, which equals the mass of the bob, which is going to be 4, plus the gravitational field strength, which is 10 times the h, times h, and h is this guy here, it's that height, it's the height above the baseline, and I don't know what that h is. I can find it though, and once you see how to find it, it becomes something that you remember. So this is h. Let's say this is L. This is the entire length of the string, which is the same as L out here. And let's say this is H dash, it's just the other bit. And I can say that L is equal to H dash plus H. Let's draw that again. I can say that L is equal to H plus H dash, and I want to find H, so I can say H is equal to L minus H dash, which equals L minus, and if you think about it, H dash is L cosine theta. It's the component of L along the vertical, which is L cosine theta. So that's the relationship that is not obvious until you go through this one time, and then you go, oh yeah, I get it. So we can go EMC, mechanical energy at C is equal to 4 times 10 times, and this L would be 2 minus 2 cosine 30. So EMC equals, and that's going to be it's going to be 80 minus 80 cosine 30 in the numbers that we're dealing with there. 4 times 10 is 40, times 2 is 80. So this would equal, if I can find my pen, it's 10.72 joules. So that's the amount of mechanical energy I have in my system. I want to find the speed at point B. So I know the EM at B, which equals 10.72 because it's the same. Now it equals the kinetic energy at B plus the U gravitational, the gravitational potential energy at B. And because this is the bottom of the swing, I know that EMB, which equals 10.72, is equal to the KE at B, which is a half times M times V squared plus. We know this is 0 because it's the bottom of the swing. So then I say, oh, 1/2 times mass is 4 times V squared is equal to 10.72. So V squared is equal to 10.72 divided by 2. So V is equal to, I say, 10.72 divided by 2. And I go second square root, second answer. And I'm going to get V is equal to 2.31 meters per second. So there's my answer, and there it is. So just to recap, the principle is that because it's an isolated system, because there's no friction, the mechanical energy at any point on this path is going to be constant. And if I can work out the mechanical energy at one point, I can then apply that mechanical energy to another point. So if I can work out my mechanical energy at C, I can then apply that to my mechanical energy at B. And so that's the first thing I did. I worked out my mechanical energy at C, and I recognized it was 10.72 joules. And then knowing the mechanical energy at C, I know the mechanical energy at B, and I can then use the expression for gravitational potential energy. Use the expression for kinetic energy to determine what my speed was at point B. There was a little wrinkle in the way in that, unless you've seen this before, the first time people see this, it's not something you just readily would notice. But once you've seen it, it tends to be something that people don't forget. It's just a bit of trigonometry. That's the one wrinkle in there. The rest is pretty standard stuff. So there we have it.